So the first question, find the tangent line to this function at that point. The nice thing about this is that they actually give you the x and the y to plug in. The not nice thing is that you have to take the derivative implicitly. So I'm going to take d dx, right? Derivative with respect to x. That's what this is, of the whole thing. I mean, this is already 0. So the derivative of 0 is going to be 0. So derivative with respect to x of x third is 3x squared. The letters are the same, so I just do it like I normally do. Same thing here. The derivative of negative 2x is negative 2. Now, the derivative of y squared is 2y, but this is with respect to x. So when the letters don't match, you have to take the derivative of y on the inside, which is the chain rule part. So you just add dy dx to this guy. And then equal, well, hello, the derivative of 0 is 0. Now I have to take everything that does not have a dy dx and put it to the other side. All right, so I have to subtract that and I have to add that. So I may as well write the positive one first. So I have 2y equals, add the 2 to that side, subtract the 3x to that side, 3x squared, sorry. And then I totally forgot my dy dx. dy dx. Let that be a lesson. I mean, I'm solving for this. It needs to be there. So maybe I did that on purpose. I didn't. Divide by 2y to get the dy dx alone. So that crosses out. So this is what you get for dy dx. This is the derivative of y with respect to x. 2 take away 3x squared divided by 2y. Now, this is where you would normally be done. Unfortunately, you are not done. I have to plug in x is negative 2 and y is 2. Why? I need the slope of my tangent line. I need my m. So I have to plug into this. So in order to get my m, I replace everywhere I see an x, I put a negative 2. And everywhere I see y, I put 2. I'm not liking how my marker is writing. Let's switch here. Hope this one is better. It's writing a little lightly. It's bothering me. Negative 2 squared is 4. And then I'm going to hit that with negative 3. So that gives me negative 12. I mean, you got to skip a little bit of steps here. 2 times 2 is 4. 2 take away 12 is negative 10. Now I'm going to reduce that, and then I'm going to have to erase a little bit because I'm not going to be able to fit all this. So the slope is negative 5 over 2. What am I doing? I just cut the numbers in half. 10 and 4 are even. I want you to reduce. Don't leave it as 10 over 4. Why not make the number smaller and reduce it? So this is the slope of my tangent line. Now I'm not quite done, right? I took my derivative. I got my dy dx. I plugged x and y into it and I got my m, but now I need to find my b. All right, so the continuation, I mean, I ran out of space, so obviously I had to do this again. I like this formula because it's less complex and it leads to less mistakes. So I'm going to put the slope m, negative 5 over 2, where the m is. X is negative 2. B is what I'm looking for, and then y is 2. Now, I can just cross these. I mean, you don't have to. You get negative and negative is positive. You get 10 over 2, right? Which is 5. So, or you can just cross out these 2's and put negative 5, negative 1 is 5. Either way, you get a 5. Just be careful with the signs, right? I made it come out nice. I made this fraction disappear. So the b is not going to be a fraction. Subtract 5. I mean, this is just way easier to do than the alternative formulas. So you get y equals negative 5 over 2x, right? Your m is negative 5 over 2, minus 3. This is your tangent line. At that point, this tangent line would be different if I change the point. At that particular moment in time, this is the tangent line. All right, so once again, find the tangent line to this thing, blah, 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 blah. 4 cos x minus sine 2y minus 3x equal 1. I'm going to take d dx both sides. Remember, please, you do not write dy dx here. This is an error. If you write dy dx, you're going to lose a point because it is not correct. I take the derivative with respect to x of 4 cos x. The derivative of cosine is negative sine. So I'm going to have negative 4 sine x. If it has an x, you do the derivative like normal. You don't do anything different. So done. Now I need the derivative of sine 2y. So the derivative of sine 2y is cosine 2y. But now I need the derivative of 2y. The derivative of 2y is 2 dy dx. You got to take this 2 here and put, right, the derivative of 2y is not 1. It's not just dy dx. You have the dy dx y because the letters don't match. As soon as you take the derivative of something with a y, you have to put dy dx there. Take the derivative of negative 3x, you get negative 3. And take the derivative of 1, you get 0. Now I'm going to add him to that side. And I'm going to add him to the other side. So I eliminate them. He's going to be gone. He's going to be gone. So I'm going to have negative 2 cos 2y dy dx on the left. On the right, I'm going to have a plus 3 and then a plus 4 sine x. You can write it in any order that you want. Now I'm going to divide this and put it under there. So just do that. I want to save myself a little space here. So that's my dy dx. You know, these are not nice questions. They're pretty bad. Now, x was 0 degrees and y was 180 degrees, right? Y is pi. Pi is 180 degrees. No, it's not. It's 3.14. It's 3.14 radians. It is 180 degrees because we're plugging in to evaluate. So now I need my m. Wherever I see x, I'm going to put 0. And wherever I see y, I'm going to put pi. Now, what's awesome about this is the sign of 0 is 0. Yay! So that's going to be gone completely. The cosine of pi is negative 1, but I don't have pi. I have 2 pi. 2 pi is 360. So the cosine of 2 pi, which is 360, is 1. So I have negative 2 times 1, which is negative 2 on the bottom. So unfortunately, my slope is going to be a fraction again. It is what it is. I mean, there's nothing you can do. You get what you get. So my slope is negative 3 over 2. So now, again, I'm going to erase all of this so I can continue it and try to figure out what the b is. It's not going to be nice, and it's going to have a pi in it. All right, so you write your tangent line, which is mx plus b. Now, as I just pointed out while I was paused, this is b. You'll see when I plug it in that this is what I'm about to do is kind of completely pointless. So y is pi, m is negative 3 over 2, but x is 0. So whatever you put here is going to get zeroed out, and b is going to end up being just what's over here. So you actually, this was almost completely pointless. You just get b equals pi. So you get y equals negative 3 over 2x plus pi. Yay! That's my b. Now, some of you write your pi a little weird. Some of you write this or this. This is not pi. I don't know what the hell this is. Try to write. I'm not going to deduct points for it because I know you mean pi, but try not to write that. It's a little weird. I do see people do it occasionally. Now, I will tell you what is a mistake is that people write this down. This is not equal to this. This x is actually up there. I mean, if you wrote negative 3x over 2, I'm okay with this because that's what this means. X goes on the top here. You cannot put the x on the bottom. You have to be really careful when you write these. Some of you wrote it a little funky. I was nice and I didn't take points off. But this is the proper way to write that, not this. So you don't do that. You can do that if you want. Okay, so this is the second example.